All right, today we are working on sections 2.3 and 2.4. So we're doing the 2 pages that say guided notes worksheet number 3/4 on the top. And today we're getting more into what are transformations. So there are two different types of transformations. The first is an isometric transformation or a rigid motion. And that means that we are preserving the angle and distance between points. All right, so for example, all of these angles are going to be the same. So angle C and C prime are going to be the same measure, and then the distance from C to D should be the same distance from C prime to D prime. So rotations means that we've just turned something, but we haven't changed the angle or distance of the points at all. So they are isometric. Translations. So here, rotation is a turn. You probably knew that. Translations are a slide. So that just means we've taken something and shifted it in some way. So that's not changing the angle or the point distance either. Or distance between points, you can also think of as side length of your figure. And reflections are a flip. So if I take something and I flip it over a line, the angle's still the same, the side length is still the same, so that's isometric. A non-isometric transformation is exactly what it sounds like. It's the opposite. So does not preserve angle or distance between points. All right, dilation is another big transformation where we take something and we make it twice as big, or we can make it half as big. But the side lengths are different. They've gotten bigger. So this is not isometric. Stretches, same thing. Your side lengths have gotten bigger. But also, a dilation is proportional. Just FYI for later. Like if this is a dilation of 2, it's twice as big exactly on all sides. A stretch is similar, but it's not proportional. This one looks like it's only been stretched left and right, but not also vertically. And then same here. It's also a stretch, and it looks like it's stretched just about in the same way. So same reason it is not, because even if L and K prime are the same, there's a big difference between LM and L prime M prime. So what is a stretch? Oh, well, so a stretch is not proportional, but you are making it bigger or smaller in some way. A dilation is still changing size, but it's proportional. Circle which of the following are isometric transformations. So that's a reflection, a rotation, or a translation. So if this is our pre-image, this would not be isometric because it changed size. Same here, it changed sides. But this would be because all it's done has been turned about 90 degrees clockwise. All right. Use the previous example to determine which transformation took place. So here, it looks proportional. Like our dog still looks normal. He's not warped in any way. So this is a dilation. And if I had to take a guess, I would say it's a dilation of 1/2. He's about half the size he was originally. Here, he's kind of warped. He's definitely been made bigger left and right, but not necessarily up and down, or at least not in the same ratio. He's no longer proportional, so we would call this a stretch. And then I think I already gave this one away, but he has been rotated about 90 degrees clockwise. All right, so next page for us. It looks like we're still just doing a couple more. Circle which of the following are isometric. So that means that they have the same size and angle between their points. So this is our pre-image. I would say that this looks about the same size. Same here, but this one is warped, so it's not the same size anymore. So if we look at what happened, this one looks like it was rotated about 90 degrees counterclockwise this time. B is a mirror image, so that's a reflection. And then C looks like it was stretched. It's definitely been expanded left to right, but it's kind of squished up and down, so it was not proportional. All right, number 5, determine the coordinates of the image, plot the image, and determine if it is an isometric transformation or not. So here they're telling us these 3 points, and they're saying our rule is that our x stays the same and our y is the opposite sign. So I'm going to go ahead and put all of my x's back in because they're the same. And my y's are the opposite sign. So now this is a -1, a -4, and a -1. So I'm going to go ahead and plot it. And we're going to decide if it's isometric or not. All right, and I should label these. So one, A prime, B prime, and C prime. So this is isometric. It looks like all of our angles would be the same and all of our distances would be the same. And if we really wanted to check, we could use our distance formula. But this is, it looks like a reflection. Like we're reflecting right over this x-axis. We're taking it from the top and flipping it to the bottom. All right, so we're going to do it again. This time they're telling us that we have x and -2y, so they're saying our x's stay the same. So I'm going to write those down, and then you're taking your y's times -2. So this is still 0. You'd have -6 and 0, and we'll plot those. So here's my A prime. 1, -6 is B prime, and 5, 0 is C prime. All right. So I would say that this is for sure not isometric, because if you look at from A to B, that looks way shorter than A prime to B prime. You could use the distance formula to check, but I would say it's obvious just by looking at it that this is a lot bigger. So this I would say is a stretch. I don't think it's proportional because only y was taken times 2. X would also have to be taken times 2 for it to be a dilation. So since it's not proportional, it's a stretch. All right. So you are working on pages 25 and 26 in your packet today. They should say worksheet 3/4 at the top.